Alright, y'all. In this video, we're going to talk about the derivative or the instantaneous rate of change or the slope of the tangent line again. But we're going to talk about how we can just use the power rule rather than either of those limit expressions that we just saw in the last two videos. So let's say it asks to find the derivative f prime of x of the following functions. At any point, I could use, I'll show you these again, this expression, or if I'm given a specific point, this limit expression right there. But we can also use something that we call a power rule to move this process a little bit quicker. So anytime I have the derivative, what happens is my coefficient of my derivative is always the power from the original function times the coefficient in front. So 3 times 2 is 6. And then my power on the derivative is always 1 less than this one. So if this was 3, now my power would be 2. So my derivative of f of x for this would be 6x squared. Let's try this next one. The same thing applies when we have a sum or a difference. I'm just going to take the derivative of each separate term and have the sum or difference of those separate ones. So the derivative of f of x would be 4 times 3 is 12. X to the 1 less would be third power. Minus 2 times 3 would be minus 6. X 1 less would be squared. And then if I just have a constant, you can think about that as x to the 0. So 0 times 5 would be 0. So I have plus 0 or nothing for right there. So my derivative would be 12x cubed minus 6x squared. Okay? Last one, anytime I see something that looks like this, I just have to be careful because the power rule only works when I have a power to a base to a power. So I need it in this form before I can start. I can't have a fraction with my base and my power. So I just need to rewrite this. Anytime I have an exponent on the bottom, that's the same as having a negative exponent. So x to the negative 2 power is the same as 1 over x squared. And because this is a base to a power, I can use the power rule and say that the derivative of f of x would be negative 2 times 1 is negative 2. X to the, and if I take away 1 from negative 2, I end up at the negative third power. So you could write that like this, but typically I'm going to write this back in fraction form. So negative 2 over x cubed, because that negative exponent would be the same thing as having x cubed on the bottom.